MTDCNC have travelled to Germany today. We're at Tuttlingen. We're here at the Chiron Open House. We're here on behalf of the Engineering Technology Group. Without further ado, let's get inside and see the latest in machine tool technology in action. Graham, firstly, thanks for the invitation to come to Chiron this week. Just tell us about, you brought some engineers with us as well, how many people you brought along and what your aim is for the week.
Yeah, I mean, first of all, Paul, thank you very much for joining us on this trip as well, and we like to get that out into the media. Yeah, we've brought along 32 customers from the UK that potentially have been working on various projects with us, and we wanted to give them a total overview of technology, automation, Chiron's capability and what they're going to do for the future.
Okay, let's start over here. I just want you to tell me quickly what this cell is here and what it's doing.
Yeah, this cell, as you see here, is Chiron have recently purchased a company, Chiron Feinbau, which has then given them an opportunity to move into doing more mill turn projects. So what we've got here is a dedicated turning and milling centre. What we're looking is for high productivity through this cell, and that's what we're gaining in the UK, is more of our customers wanting this level of automation and productivity, but this allows us to be able to do turning and milling all in one operation.
You've got a vertical lathe there, or two vertical spindles, haven't you? And then you've got a twin spindle machining centre here, 5-axis machine.
Yes, absolutely, that's what we do. We've got a pickup spindle in the shearer, so the parts will actually come in on a conveyor system. The main spindle itself will pick it up, do all of the turning for op 10, transfer to op 20, and then the Chiron twin pallet machine, double spindle, allows us to be able to transfer the part through the automated robot, part out the cell, 80 seconds, complete.
Holger, we're at Neuhausen here. Can you tell us what's happening in this unit?
We are here in the supermarket, and we get the material coming in from the trucks, and we split it into the different assembly lines. It's the 15, 18 on this side, and the other side is the 08 and 12 assembly lines. So they got split and prepared for assembly to get the tech flow working in the hall itself.
In terms of the Chiron machines, are they your most popular sellers, the machines you just mentioned?
Yeah, we have the most sellers is the 15, the 12, 08, the most series. So the 15 now gets overworked right now. It's one of the oldest one, but very successful model.
Okay, I can't wait. We need to go in and see this assembly line. Let's go and have a look. 3 assembly lines in here, but this is where it all starts. What have we got here, Holger?
We got the cabinets coming in here, the electric cabinets, the cabin itself from the machine, and the pre-assembled columns. As you see here, there's a basket tool changer column ready to go into the tech assembly line.
It's great to see the machines in this way. Let's move on now to the full assembly line. I think what's really impressive here is, as a machine, you have a process, don't you, where the machines move down the line. Tell us about that.
Yeah, as you see here, there's a machine bed coming into the next step, and we have big screens on the hall mounted, and these screens show the next assembly teched. And we have kind of a hovercraft system with 4 plates, get fully air into it, and then the machine moves by manpower. They move it one step to each other, and this is done for 12 lines within 30 minutes in time. The whole line get moved, so
it's a real production line, isn't it?
It's real production and tech assembly like in the automotive. So we increase quality and delivery time doing this, right? So every station has the same input, and we got very good control on the delivery and service and the quality itself on the machine itself.
We love seeing machines in this state here, because you can see everything from the machine's casings to the guideways, to the spindles, to the tool changers. Just tell us, I mean, what's this guy doing here? Is he putting the outsides of the machines together?
Yeah, here the machine has been mounted with the cabin on the station before, and he's now installing the automatic doors and making the guideways working well.
And every stage as we go, the machine's getting closer to the finished article, isn't it?
Yeah, in one stage we got the mounting, then we have the commissioning. First time the control gets working, we put the voltage on it and get the software running. And the next steps, we have tool changer test field. We install the tool changer working. You listen the up and downs on the basket here. Then we have the table working, and every station is more and more to the final machine assembly then.
What happens if one gets behind? What happens if there's a problem? Does it stop the whole production line?
We have people also noise system, right? And they ring the bell, so somebody comes, and if they have a problem, they help them out. We have jumpers. They do this, right? And as you see the traffic light on the left on top, this shows if everything is okay. It's green. If it's yellow, oh, something got wrong. If it's red, we need urgent help. So, and this helps also pre-looking like a forecast what's going on with the machine.
So you've got certain guys that kind of float between the different principal operations. So if there's a problem, they can move to another machine and fix it, so that you keep the production going.
Yeah, but the people have a very high knowledge of their assembly education, and they are all able to do most of the geometric work, all mechanics. Then we have a team of commissioning guys, electronics, electric, and then the final check.
Well, this is where we see the machine moving around, and what we can't lose sight of is the sophistication of the machine tools we've got here. We're talking about twin pallet machining centres, aren't we? Very high speed tool changers, chip to chip time, extreme production machines.
Yes, it's right. And for example, here we have a basket tool changer. It's still the fastest one in the world. We have less than 1 second tool change time, and chip to chip is about 2 seconds. And they got used here for wheels production, and it's just important to have high uptime, high availability on the machine, and the machine needs to go 3 shifts a day working, so it's really needed that the test profile is very high level.
And here we are really looking at almost a polished finished article, aren't we, as we move down this line?
Yeah, this is the final stages, right? They check up if the color's right, if the bolts are all correct, the color matching the plan. And then they got a test field doing, the machine runs at least 100 hours endurance run to find all the bugs. And if it's fulfilled, they run the machines with fully water, fully options, and then they have the final check, and then the packing comes and the truck can load.
So you do 100 hours of testing on a machine?
Every machine. Every hour which is left, the machine will run, even weekends, overnight. The more they ran, the better it is to have a tested profile.
The clocks here as well. Just give us a final point on what these clocks are saying.
The clock says here it's in 13 hours the line 3 will move by the people, and this means nearly 2 days we get the movement right on the hovercraft, as I told you, right?
So that's the deadline. That's basically when the production line moves forward. How many machines are coming through here, Holger? How many machines are going out that door?
We are each line of about 150 machines capability. So in the hall here, it's 450 machines building possible. Last year we did about 800 machines in the group. So it's all organized the same. We will later on see in the main company the same, but it's quite high output, I would say.
And you need to have a facility like this, don't you, to keep that volume of machines coming through. I tell you what, it has been a really fantastic insight here to what happens at Neuhausen. We're going to head out of the door, the same place that the machine goes out. So thanks a lot, Helmut.
Yes, thank you also, and enjoy the time.
Some of these machines here, I mean, the baseline, we've seen a lot of these in the UK market. I'm probably more interested for this discussion here about the Vario cell. Can you tell me about this machine? If we move a bit closer, let's.
Yeah. I mean, what's important here and what we're seeing in the UK is that for our customers to be able to compete in global markets, the level of automation, lights out running, is very, very key to their business. And what Chiron did was to be able to integrate their own robot system onto their own machines as effectively a bolt-on in their technical hall. What this does here is the robot is actually picking the parts from a dedicated tray. So all of the raw billets are coming in there, no pallet systems in there. We're literally picking the part directly into the 4th or 5th axis on the machine.
How do you fill that tray of up with material? Do you have to go in and physically, while the machine's machining, and add parts to it?
No, very, very simple. During cycle or out of cycle, it's not a problem. We've got dedicated trays round the back of the machine. There is a cabinet. that the operator is loading the raw billets into those trays, and then there's a conveyor system inside there that the robot is rotating that carousel to be able to pull the tray out into the machine. Very, very simple.
You said, I think you used the word bolt on it. Are we saying then that this can be added to any of your Chiron machines, this type of automation?
Yes, it can be. I mean, all of the Chiron machines with a certain level of retrofit capability on it, but they have dedicated to a whole of their series. So if somebody came along 2 years into a Chiron purchase and said, hey, I want to automate that machine, I'd like to move forward with that, Chiron can come out in the field and actually fit that system to the machine.
This a 5-axis machine in here?
Yeah, this is a full 5-axis from the 12 series, yeah.
And this, just looking at the working envelope, you've got 550 by 400. You've got 44 kilowatts of power in the spindle. That's pretty extreme, isn't it?
Yeah, I think I mean, Chiron weren't renowned for their milling capability in the very early days because it was more of a high-speed drilling and tapping centre. But what we're looking for, 5-axis, you have to have that capability for milling. So a lot of work's gone into getting the power right, the spindles right, and the process is right to be able to give that level of...
So it's not just about machining aluminium anymore then, is it?
Absolutely
Let's
not.
move this way. This machine's obviously quite busy, but again here we've got is this a twin pallet machine in here?
No, this is not. This is a standard 5-axis single pallet system machine. But where this machine has moved forward, this is now what's called the Precision Plus. And what Chiron have done is develop their FZ08 range with more dynamics, linear motors, higher spindle speeds, for very, very precise components where we've got very, very small tolerances, but surface finish requirement is also very crucial.
I want to come back to the linear motor one now as we move to this machine, because this is a big highlight for me here, and I know for some of your UK engineers coming here. Linear drive motors versus ball screw. Give me your take on the two and the differences.
Well, as you can see on this demo, where Chiron have been very, very big in the turbocharger market, is obviously producing impellers. So they've got some very, very big coverage worldwide making those particular components. Where the enhancements have been made is that as these impellers are moving up in speed to 300,000 RPM, surface finish quality is absolutely key, and to the balancing of those particular components as well. And where you have a dedicated impeller where you're making very, very small movements on a ball screw, there is potential wear patterns that are going to come into that which could affect the surface finish and quality, but the linear motor, we don't have to worry about that, and it gives us fantastic repetition.
So this is this new to Chiron?
Absolutely, this is now being launched as of today from this open house. Chiron, as they do with all of their research and development, as they're putting a program together, will actually beta test that at one of their biggest customers in this particular field in the market, and the results that have come back from that have been absolutely fantastic, with roughly around about a 30% productivity gain over the existing ball screw machines they're using.
That's a lot. I can see what you mean with the ball screw here, or the ball screw element, having to do a lot of movements very quickly over a period of time. There could be wear in that, but with linear drive motors, there is none, is there?
Absolutely not. That's exactly why we're moving there, and that's why a lot of people have come to be able to see the launch of this machine, because it's now available for sale.
What about the cost of actually running a machine with a linear drive motor compared to a ball screw? Is it a bit more costly?
Yeah, I mean, looking at some of the figures that Chiron did, they're very big on cost of ownership. So when they're actually looking at all of this, they're actually looking at what the potential running costs of that could be. Linear motors do actually draw a little bit more power, but certainly with the drives and the low energy drives that Siemens have been developing as well with them, it's actually taking that back. So where you could have probably looked at about 10% extra power requirement, they've probably brought that back to about 2 or 3%, which for the gains that this is going to give over its lifetime, it's probably quite a small amount.
I also think there's another argument with this about the control element, because you can have a machine that is very, very fast acceleration, rapids and all the rest of it, but this control has got to process all that to get the finished part, hasn't it?
Absolutely, and I think where we've got a series of controls that Chiron offer here, which is obviously Siemens 840D, Fanuc 31i B5, and then Heidenheim TNC 630. But we tend to find that on this type of project, the Siemens tends to run around about 10 to 15% faster. So they've really done a lot of development on that drive system and the control processing speeds to meet up with the demand of this machine technically.
So control can keep up with the speed?
Absolutely.
And it has to. I want to look at two more machines quickly. This one here, one of the things I like about this is the inventiveness of your work holding here, the fact you've got 4 components here on a work holding system, so you can tackle 4 parts at once, essentially, can't you?
Chiron do a lot of twin pallet systems, obviously, but on a single pallet 5-axis machine, not quite so easy. So the benefit here is to look at how many components you can actually get in there to increase the cycle time so that the operator can get on with the other operations, but give you the ability to reach over the job. So this concept, very, very clear. We can set up 4 parts very easily on a 5-axis.
And this is a fast 5-axis machine as well, isn't it?
Absolutely. I mean, the 18, Chiron their strap line is seconds ahead, so they don't want to be beaten on anything, so they will come up with a concept to do that.
Okay, I want to move on to something different to conclude this. And again, I know these machines are attracting a lot of attention this week. Tell me a little bit about the Mill series.
Yeah. The Mill series is, well, it's a very important machine to us in the UK. We have a very good automotive structural part customer base, and also into structural parts in aerospace. So this machine lends itself very much for those sort of capabilities. And the dynamic mill was the next stage of being able to redesign the column structure to be able to get the machine much faster, from a 45 metre to a 75 metre, 1.5G drives, increased spindle speeds, and make it a more of a dynamic animal for eating aluminium billet.
So it's a high-speed column moving machine, isn't it?
Absolutely, all Chiron machines are moving column machines, no travelling tables whatsoever.
And I also like the way the tool changer here is always with the RAM, essentially, isn't it? Because you don't want any downtime when you're trying to change the tools.
Yeah. The issue you have with a lot of long bed style machines is you have to retract to an X0, Y0 position. So you're moving to the extremes of the travel limits. Here, what Chiron have done is going right the way back to their basket changer methodology, that you move up in Z, change tool and continue. The same goes on with the Mill series. They've developed that in where the tools are in the chain as part of the column, and that's driving up so that you just come up in Z, both come together, you change tool very simply.
If you had a tool changer at this end and you were machining at that end, that could take seconds to get to and from to change your tool. I can see the benefit totally. I want to mention one more thing, Y-axis on this. Quite large, quite extensive.
Yeah, I mean, where we were always struggling a little bit with the previous Mill series was obviously the Y stroke. So where we were sort of limited to a 610 Y stroke, we're finding that we're getting wider components. So part of the development has now took that out to 840 in the Y.
Is this a demonstration that Chiron aren't just about small, nimble parts, it's about structures and larger components as well?
Absolutely, and it gives us the ability to offer a lot of solutions to our customers, and we think with this machine we've got a very, very good stable solution.
And it's all about turnkeys as well with the engineering technology group too, isn't it? It's not just about shifting boxes for machines, it's about helping customers produce a part on a turnkey solution.
I think our strategy in the UK is definitely that way, and we want to be seen in the UK market as a solution provider. So we're not just box shifters anymore, we are dedicated to having the applications teams that are going to meet the demands of our customers for the future.
Thomas, Chiron put a big emphasis and focus on training from a very young age as well. Tell me about your role here.
I'm here a trainer for the mechatronics and the electronics, and also did my apprenticeship here.
And what age? I see some very young faces in here. What age do they start in Germany or here training to be a mechanical or an electrical engineer?
Normally they start with 15 or 16 years after the school and then come to us.
I've seen there's one gentleman here, well, one young lad here who's 13, so how does that work?
That's a guy from school who wants to know what he will make a trainee in, so probably of mechatronic or...
So it's a little bit like work experience. They come here to see whether they want to become an engineer at a very young age.
Yes, but they get to know all different departments, and so they know where they want to go after that.
And you've got quite a good mix of females as well as males as well. How many young girls do you get through here?
At the moment we have about 6 girls here in our apprenticeship. So.
And tell me about what they're going to do here in this department. Are they going to get their hands on lathes, milling machines, electrical? What's some of the things they do?
They make short parts like motor in their trainee, so to get to know all the machines and the processes here.
So how many apprentices would you have here in this school at the moment?
We have per year about 30, 32 around this.
And when they finish their apprenticeship, how many go on to work for Chiron?
Normally all go to work here, but some of them go to school again but come back later.
Roger, it's fascinating to walk around some of these halls and see the machines in action and what they've made. What's your role here at Chiron?
You know, we deliver to our customer a finished turnkey machine. That means we're going to get a machine, a standalone machine from our flow assembly, and we equip it with the fixture, with tooling, with the automation. So we're living actually from the part. You know, we develop the process for manufacture the parts.
And this is your role, this is what you head up. You are the technical director, essentially.
Exactly. You know, in that application, we have the fixture department. They develop the fixture, which is coming to the machine. We have the tooling department, automation, application engineer, simulation of the process.
And give me some numbers. How many turnkeys are you delivering a year here at Chiron?
We make around 200 turnkeys a year.
And how would that compare to normal machine sales without turnkey?
You know, overall, Chiron is delivering here at Chiron, not in the group, because in the group we have Stama and Shara as well. We have around 600 machines, so that's a third.
And is that growing, you know, around the world?
It's growing extremely.
Why do you think turnkeys are becoming more popular and more required?
Because we supply a finished process. You know, it's more difficult for the customer if you're going to buy the fixture and the tooling or the automation separately from different suppliers, so we bring everything together.
We're here on behalf of the Engineering Technology Group who supply your machines in the UK. Have you been involved in many turnkey projects overseas in the UK?
Absolutely. We work very close together with the ETG, you know, and we do most of the turnkeys we still do here at Chiron, you know. We get the guys from them and we do it together over here.
And do you see any specific markets where your turnkeys are most successful? I mean, are we talking automotive, aerospace, medical components?
You know, medical is very important for us as well, but 65-70% is automotive, and especially also in the UK, it's automotive or aerospace.
So if turnkeys are becoming more prominent, you're going to get even busier yourself then?
Absolutely, absolutely.
Has it been a good show?
For us, it's a very important show, you know, and we have around 2,000 guests over the 3 days, so it's a very important exhibition for us.
What do you want engineers going away thinking about Chiron?
You know, that we have really a complete solution to everything. You know, what I explained before, we are living from the part. We get a raw material part from the customer, and that they can really see over here what is our competence, you know.
Are you the best at the world at this?
Absolutely. In vertical machining, we are the best in the world for us. Because, you know, the best in the world does not mean the fastest machine. We have very fast machines, but to deliver a whole turnkey, you know, there we think we are going in the right direction.